What is up, guys? This is Luke Hill for Kit Guru, and these are AMD's new Ryzen 3 Zen 2 processors, so the new budget mainstream offerings. Let's see how they perform. We already know a lot of the details about these Ryzen 3 chips because AMD announced them recently. They are 4-core, 8-thread Zen 2 based parts. Each of them has 16 megs of level 3 cache and obviously 2 megs of level 2 cache because they're 4-core parts. The 3300X is $120 US, probably about 115 or 120 pounds in the UK, and the 3100 is $99 US. One of the key differences between the two is the clock speed. So the 3300X is 3.8 GHz base clock and up to 4.3 GHz boost, so pretty lofty on that boost frequency, whereas the 3100 is 3.6 base and up to 3.9 GHz on the boost. The other key difference between them is something that you can't actually see or tell by looking at the specification sheet. So the 3300X is actually a single CCX design, so it has the one core complex. So its entire 4-core, 8-thread, 16 megs of L3 cache comes from a single 7nm Zen 2 CCX. Now both of them are single CCD chiplet designs, but the 3100 is a dual CCX design, so it has two Zen 2 CCXs, each with 2 cores and 4 threads and 8 megabytes of L3 cache. So these are quite heavily cut down Zen 2 CCXs in the 3100. And the reason that point is interesting is because AMD suggests that this could alleviate some of the inter-CCX latency that we see with some of the higher end parts. That could translate into better gaming performance. We'll have to wait and see. And then obviously your general housekeeping for the rest of the specifications, 65 watt TDPs on both of them, which means they'll do up to about 88 watts of package power in usage. Wraith Stealth CPU cooler, so it should be perfectly fine unless you're overclocking quite hard. AM4 platform, ideally partnered with B450 or upcoming B550 motherboards because of the cost. Dual channel DDR4 memory support. We still suggest DDR4 3600 if you can afford it, or 3200 with tight timers is pretty reasonable at this cost point. Of course, the same number of PCIe Gen 4 lanes, so 16 plus 4 plus 4, and you get the unlocked multiplier if you do want to tinker with overclocking. Given the launch timescale for these parts at the beginning of May, the competitors are actually a bit tricky to understand. So currently the 7nm Zen 2 parts actually go up against some of Intel's 9th gen Coffee Lake refresh lineup. So most notably you get the Core i3 9100F, and that's about £70 in the UK, so significantly cheaper than the Zen 2 parts. And then you've got the Core i5 9400F, and that's a 6-core, 6-thread. The i3 is 4-core, 4-thread. So neither of those have hyper-threading. The i5 is more expensive, about £140 in the UK. So there's kind of this valley in Intel's range where the Zen 2 parts sit in quite nicely, and they don't have any real justifiable Intel competitor that you should seriously consider purchasing. The i3 is cheaper, the i5 is more expensive. Obviously the other key difference also is that you don't get unlocked core ratio multipliers with the Intel competitors above and below the price point, so you can't really overclock them. Their frequencies are alright out of the box, but you can't really overclock them. And if you want to have high-speed memory support like the Zen chip, you'll need a Z series motherboard, but they're pretty affordable to be fair, even though they are more expensive than B450 in general. While these are the current competitors somewhat from Intel's 9th gen lineup, according to rumours, the upcoming Core i3 Comet Lake S processor should be pretty interesting competitors versus Ryzen 3. The rumours suggested on sites say that the new i3 is going to be 4 cores, 8 threads, pretty lofty frequencies out of the box, and affordable at something like $122 if I remember correctly for the 1KU tray pricing, so similar price to the 3300X. Of course, we can't go into any more details right now because we simply don't know them, we don't have the chips on hand, we don't know the performance, but keep an eye out over the next few weeks because these could have tough competition from some of the new Intel chips. Jumping back to the other current competitors for the Ryzen 3 3000 chips, the obvious ones would be the Ryzen 3000 APUs. They're not really direct competitors because they're APUs and they're older Zen architecture. The realistic competitor for these CPUs is the Value King Ryzen 5 1600AF. So that 6-core, 12-thread part is a Zen plus 12nm based processor. It's got mid 3 GHz on the all-core frequency, so probably lose a little bit when it comes to frequency-intensive tasks, but you get 6 cores, 12 threads, and the sample that we went out and bought recently was £99 in the UK, so clearly going to be a tough competitor. It'll be interesting to see how that one plays out. Maybe the 7nm process node will bring efficiency gains that are beneficial, and the Zen 2 architecture should be quicker in gaming, but 6 cores, 12 threads at a similar price point, that's going to be pretty tough. Anyway, I think that's enough for our brief introduction. We know most of the parameters of Zen 2 at this point, so let's have a look how the new Ryzen 3 3000 chips compare against the Ryzen 5 1600AF, Core i3, Core i5, and also the old trusty Core i7 7700K. Interesting comparison point nonetheless. Our test system uses the Asus TUF Gaming X570 Plus motherboard, which proved to be an excellent value option in previous testing. We could have used a B450 option, but we wanted to use an overpowered motherboard to isolate CPU-specific performance during our testing. We're using the latest BIOS with a GSO 1004. The CPU cooler is an Arctic Freezer 33 Esports 1. This £20 budget 92mm tower cooler is not out of place with CPUs at this price point, and it allows us to get comparable data across the Intel and AMD platforms. We'll also have a look at how the bundled Wraith Stealth performs later in the review. For memory, we're using 3200MHz G.Skill Flare X C14 16GB kit, and this is Samsung B-Die DDR4. Power comes from the absolute beast of a power supply, so the Seasonic Prime Titanium 1000 watt power supply, which gives us a lot of clean power, and dual 8-pin connectors. When it comes to pixel push-in power, we're using the beastly Gigabyte Aorus RTX 2080 Ti Extreme, and this is an absolute overkill graphics card for the enthusiast gamers, and we use a custom fan curve on this to eliminate thermal throttling and ensure consistency between test platforms. If you want more details on our test system, the comparison test systems, and our test procedures, head on over to the KitGuru website where it's all written there in full detail. Let's get into the performance. Cinebench R20 gives us a first look at the 4-core 8-thread Ryzen 3 Zen 2 chips. Multi-core performance is clearly a strength with AMD's new value processors. The 3100 keeps pace with the more expensive Core i5 9400F hexa-core and absolutely destroys the £70 Core i3 9100F. Meanwhile, the 3300X sees performance that is 9% quicker than the aging but still popular Core i7 7700K. If you want higher scores at this budget segment of the market, the £100 Ryzen 5 1600AF proves strong despite its older Zen Plus architecture. A good start for the Ryzen 3 chips, we'd say. The Ryzen 3 3300X held stable at around 4.2 to 4.3 GHz throughout our Cinebench runs with the Arctic cooler. The 3100 was happy at its maximum boost value of 3.9 GHz non-stop. Thanks to its lofty 4.3 GHz boost frequency, the 3300X hits joint top position with just over 500 points in Cinebench R20 1T. Around a 10% drop-off is observed when switching to the 3.9 GHz Ryzen 3 3100. But that $99 part still beats out the similarly priced Ryzen 5 1600AF, as well as the Intel competitors that run at comparable clock speeds. Ryzen 3 3300X in particular puts in another stellar display when looking at Blender's BMW test. It will take a 6-core Ryzen 5 1600AF on the older Zen Plus architecture to outperform the 3300X at this price point. Intel's current competitors are significantly slower, and even the trusty old 7700K cannot keep pace at stock clocks. We see the Ryzen 3 3100 offering competitive performance versus the £140 Core i5 9400F. Clearly there is a performance void that Intel needs to fill with Comet Lake S around the £100 to £120 price point that AMD is slotted into quite nicely. Ryzen 3 3300X outperforms the £20 to £30 more costly Core i5 9400F by 5% in our Handbrake X264 test. With that said, the £99 Ryzen 5 1600AF overcomes its older Zen Plus architecture with brute force of a dozen processing threads to beat AMD's new chip by 14%. Looking at the cost-effective Ryzen 3 3100, we see the quad-core Zen 2 part roughly matching Intel's Core i7 7700K mainstream flagship from the Kaby Lake era. That's quite the change of tides in a little over 3 years. 7-zip compression has long been a strength for AMD's Zen 2 architecture. Here we see Ryzen 3 3300X match the 6-core Ryzen 5 1600AF for the first time in our multi-threaded testing. Unsurprisingly, the slower clocked Ryzen 3 3100 drops off compared to its bigger brother. With that said, the $99 chip still manages to outshine the costlier Core i5 9400F and Core i7 7700K parts, albeit by a slim margin. Decompression sees the 1600AF put its extra threads to use to regain an 18% advantage versus the 3300X. Nevertheless, the budget Zen 2 chips offer up a performance increase of 9 to 19% over the venerable Core i7-7700K. That performance uptick for the cheap AMD parts increases to 15 to 25% versus the more expensive 9400F. Memory bandwidth falls in line with what we see from other Zen 2 based chips. As these are single CCD processors, you get the same half-speed write bandwidth that we see on Zen 2 Ryzen 3000 chips below the 12-core 3900X. Memory latency also positions roughly where we would expect it to be. The Ryzen 3 3300X looks to have a little less memory latency, and this could potentially be attributed to its single CCX design. Speaking of single CCX design, we see the Ryzen 3 3300X's inter-CCX latency is 0, as it only has the one CCX. In a lower is better scenario, this beats the 3100 and 36X's 81 nanoseconds and the 1600AF's 125 nanoseconds. The Ryzen 5 1600AF's inner CCX latency is also worse at 45 nanoseconds versus 33 to 37 nanoseconds for the Zen 2 parts, clock speed dependent. Starting our gaming comparisons with F1 2019, we see the Ryzen 3 3300X putting in a superb showing thanks to its Zen 2 architecture and lofty clock speeds that hold stable thanks to relatively light cooling requirements. Intel's competing Core i5 9400F is no slouch in this test. It manages to outperform the 3.9 GHz Ryzen 3 3100 and is very close to the speedier 3300X. It's also more expensive than both though, and therefore steals money from a graphics card purchase. Ryzen 5 1600AF still does well in this test, but the newer Zen 2 chips are tangibly faster if you're a high refresh rate 1080p gamer. Old but still immensely popular and tough to get running at high frame rates, Grand Theft Auto 5 is next up. The Ryzen 3 3300X does well in this older DX11 title that clearly favours a mix of threads and, more importantly, frequency. GTA 5 also favours the Intel architecture, which is not all that surprising given its age. As such, we see the Core i5 9400F outperforming the cheaper 3300X, albeit by a negligible margin. We also see the lower cost 9100F roughly matching the stock clocked Ryzen 3 3100. The key difference between the 4-core 4-thread Core i3 and AMD's 8-thread competitor is that the latter has some amount of CPU headroom still available. The Core i3 by comparison is glued to 100% usage. If there are positives to be taken from the somewhat mixed bag results shown in GTA 5, it is that the new $120 Ryzen 3 3300X is about as quick as a gaming elite from generations gone by, the 4.5 GHz 7700K. Plus, the Zen Plus Ryzen 5 1600AF is clearly a less than ideal choice in this title. Given that GTA 5 and Red Dead Redemption 2 are both Rockstar titles, it comes as a little surprise that we see a similar performance hierarchy. The preference for Intel Skylake-based architecture is evident yet again. Ryzen 3 3300X does pretty well to get within 10% of the high refresh rate performance offered by the more expensive 9400F and the resilient 7700K. This time around, Ryzen 5 1600AF and its dozen Zen Plus threads prove slightly quicker than the Ryzen 3 3100, which in itself is vastly superior to the stuttering 4-core 4-thread 9100F. Overall, Ryzen 3 3300X looks to be a good choice for higher than 60 FPS gaming in Red Dead Redemption 2, especially given its cost decrease versus the Core i5 9400F. Not to be ignored though, the slightly cheaper Ryzen 5 1600AF puts up a solid fight and manages to outperform the similarly priced Ryzen 3 3100. Ryzen 3 3300X hangs reasonably close to the top position in Shadow of the Tomb Raider. With that said, its reduction in frequency or cores versus the parts sitting above it do force a quite significant drop in 1% low FPS values. The Ryzen 5 1600AF is slower in terms of average FPS, but does offer higher 1% low numbers, which implies solid gaming consistency on that older 6-core alternative. Ryzen 3 3100 actually sits at the bottom of the chart when ordered by average FPS, but this is highly misleading as the Core i3 9100F is a stuttering mess as shown by its 1% low value, and is an unpleasant gaming experience at these settings. And that doesn't even reference the significant level load-in times and texture pop-ins for Intel's cheap 4-thread chip that we did not observe on any other processors with our used settings. In this title, the Ryzen 5 1600AF is hard to beat from a value perspective, but the extra £20 for the Ryzen 3 3300X will net higher average FPS numbers if your monitor goes past 100Hz. Ryzen 3 3300X is about as fast as it gets in the Division 2. Both the average and 1% low FPS numbers are excellent even for high refresh rate 1080p gamers. The more expensive Core i5 9400F is a little slower, albeit by a small margin. Switching focus to the Ryzen 3 3100, we see it battling closely with a £99 Ryzen 5 1600AF. Average FPS numbers are comparable between the two, but the 12-thread Zen Plus chip has the slight advantage in terms of 1% low performance. The Core i5-9400F is less impacted by the resolution increase to 1440p in F1 2019. That allows its average FPS performance to leapfrog the 3300X into second position. Nevertheless, nobody will complain about 167 average FPS numbers and comparable performance to the Ryzen 5 3600 from a $120 quad-core. High performance is still achieved by the Ryzen 3 3100 versus the 1600AF, but this time the margin is tight and realistically negligible in real-world gameplay. Shadow of the Tomb Raider performance barely changes from 1080p to 1440p, such as the load on the CPU and GPU. Ryzen 3 3300X still hangs close to the 9400F, 7700K and 3600X, whilst comfortably outperforming the Ryzen 5 1600AF. Speaking of the 1600AF, AMD Zen Plus Value King retains its average and 1% low FPS upper hand versus the equally priced Ryzen 3 3100. Intel's Core i3-9100F continues to be a stuttering mess at this level of demand, and the 3100 is clearly a better choice, albeit more expensive. With the higher GPU load of 1440p applied, we see performance grouping just below the 110 FPS level in the Division 2. There is little room to identify performance differences between the competing CPUs at these settings, but the Ryzen 3 3100 does struggle to keep pace with the 1600F in terms of 1% low FPS values. CPU compute performance on the Ryzen 3 3100 was overall slightly better than that of the Core i5-9400F, even though both chips draw roughly the same power. That's a good result for the 3100. Looking at the Ryzen 3 3300X, we see similar power numbers to the 4.5 GHz 7700K, but AMD Zen 2 quad-core is notably faster in our CPU compute tasks. As far as power efficiency goes, this is a clear area where the new 7nm Ryzen 3 chips managed to beat the Ryzen 5 1600AF and its 12nm fabrication node. Worth noting is that neither Ryzen 3 processor used its full 88W CPU package power allowance as dictated by the 65W TDP. That brings about the option for running the chips in a 45W TDP Eco Mode configuration with relatively little drop-off in performance for the Ryzen 3 3100 in particular. Cinebench NT performance per watt comparisons clearly favour higher multi-threading, so it is impressive to see the quad-core Ryzen 3 parts doing particularly well. The Ryzen 3 3100 offers comparable performance efficiency to Intel's Core i5-9400F, but the higher clocked 3300X leverages more energy for its performance. As proven by our use of a bargain basement £20 air cooler, it does not take a lot to cool any of these reasonable core count processors at stock clock speeds. Ryzen 3 3100 runs significantly cooler thanks to its roughly 400 MHz clock speed deficit versus the 3300X. We have observed time and time again that Zen 2 starts to get increasingly hot when pushed beyond 4 GHz clock speed. AMD's 4-core 8-thread part is just as easy to cool as the 9th gen Intel processors above and below its price point. The same comparison holds true for the 1600AF and its mid-3 GHz operating speed. While we used a budget aftermarket CPU cooler to extract maximum performance from the Ryzen processors and to make sure temperature comparable across the Intel and AMD platforms, we were keen to see how the boxed Wraith Stealth cooler would perform on the Ryzen 3 chips. At 100% fan speed on our open-air test bench, the Wraith Stealth only dropped around 50 MHz off the Precision Boost 2 all-core frequency for the Ryzen 3 3100. That came with the penalty of a 16 degrees Celsius increase in operating temperature. Switch from our Arctic Freezer 33 eSports 1 to the 3300X's included Wraith Stealth heatsink, and you can expect to lose around 150 MHz on the Precision Boost 2 algorithm when running extended all-core loads. The temperature also increased by 12 degrees Celsius to a rather toasty 85 degrees. Put simply, the included Wraith Stealth heatsink is perfectly adequate. However, when aiming to maintain frequencies beyond 4.1 GHz under all-core loading, even a budget £20 tower cooler proves a worthy upgrade. We managed to push our 3300X sample to 4.45 GHz using 1.4 volts in the Asus UEFI. This was quick and easy and proved stable, even with our budget Arctic CPU cooler. As the 3300X is already highly clocked out of the box, our overclock only added around 5 watts onto the package power draw and the actual load voltage barely changed. The 3100 pushed to 4.2 GHz on all cores using the same 1.4 volts in the Asus UEFI. CPU package power this time increased to around 75 watts under Cinebench load, so cooling the overclock chip is still a relatively easy task. I guess there's a reasonable argument that the full 4-core CCXs of the 3300X are higher quality silicon than the crippled 2-core CCXs forming the 3100. A modest but worthwhile performance gain was registered for the overclocked Ryzen 3 3300X. The 3100's gain was slightly more noticeable as it represented a larger percentage increase from its stock frequency. Interestingly, our overclock testing highlights the importance of Ryzen 3 3300X's CCX topology. The 4.2 GHz overclocked Ryzen 3 3100 is just shy of the 3300X's 4.3 GHz stock clocked frequency. However, the cheaper dual CCX part is noticeably slower in Shadow of the Tomb Raider performance. The 16 megabytes of local L3 cache and no inter-CCX latency are clearly a benefit for the Ryzen 3 3300X in certain scenarios. Overall, I'd say I'm pretty pleased with the new Zen 2 based Ryzen 3 3000 processors. I think they fill the sub £150 void that was clearly missing for Zen 2 options in AMD's lineup, so they make a lot of sense there. Clearly, the gaming performance is pretty good overall. It's actually very good on the 3300X. 4 cores, 8 threads, so, cost effective, but it's actually a very good gaming processor. It's not quite as good as the 7700K in general, but that's a really powerful gaming chip from a few years ago. Overall, I'd be perfectly happy to game on the 3300X, especially with this single CCX design, which does seem to help in certain situations. The gaming performance of the 3100 is a little bit more difficult to analyse. And the reason being is because it's priced very similarly to the Ryzen 5 1600AF, but that 6-core 12-thread Zen Plus chip proves to be a really tough competitor, even though it has older architecture. There are some games where the new Zen 2 chip will perform better, but there are instances where the higher core count of the older Ryzen 5 is beneficial. And if we extend the game performance comparison to the Intel competitors, then yes, the Core i5 9400F is a pretty tough cookie versus the Zen 2 chips, but it's also more expensive, and these are far better solutions than the Core i3 9100F, but that's also a cheaper chip. Clearly, that void there, Intel needs to fill. The compute performance, if you're someone who wants to do a bit of work on a budget, is really good. Both the Ryzen 3 chips punch well above their weight. We're talking higher than 7700K levels of performance. The Core i5 9400F was beaten most of the time, and that's a 6-core, 6-thread, more expensive part. So overall, I'd say the compute performance is pretty good. However, that venerable old Ryzen 5 1600AF, which is Zen Plus architecture, 6 cores, 12 threads, that proves a thorn in the side, because at £99, it's really tough to beat its compute performance unless you have tasks which are specifically beneficial for the Zen 2 architecture and the higher frequency typically brought about, such as AVX2 workloads. The overclocking headroom was actually quite good. I was quite surprised by the 3300X because this was pushing on 4.3 GHz out of the box. So the fact that we got up to 4450 MHz was quite impressive, and it didn't really add much power or much cooling strain. So that's pretty good if you want to tinker. The 3100 is clearly lower quality silicon, but we still managed about 4.2 GHz. You could push to 4.3 if you want to spend more time tweaking and if you kind of get a bit more lucky with the silicon lottery. But 4.2 overall, that's perfectly fine by our measure, especially when you factor in that the competing Intel chips at this price point, or even quite a bit higher, do not support overclocking, so that's a big benefit. So I think to summarize this, if you're looking for a new budget gaming chip that isn't going to steal too much money away from the budget that you can put towards a graphics card, I'd say the Ryzen 3 3300X looks like a pretty good choice, to be honest. Pair that with a B450 motherboard, some high-speed memory, and you should be set pretty well. Of course, the Ryzen 5 1600AF is still a tough competitor, and if you are looking at spending about £100 on a CPU, such as the Ryzen 3 3100, the 1600AF still needs to be put into reasonable consideration because it is a tough cookie at that £99 price point. But if you can stretch up to the £115, £120 of the 3300X, I think that's worth the extra in my opinion. Obviously, if you're just interested in compute on a budget, the 1600AF is going to be tough to beat. There are instances where Zen 2 will prove preferential, especially when it comes to power efficiency and clock speeds, but the 1600AF, with its multi-threadedness, is tough to beat for compute tasks. However, when we summarize versus Intel's current competitors, then really Ryzen 3000 is kind of a no-brainer, if you like. The new Zen 2 parts, even though they're lower core counts versus the 9400F, they are better options and they're cheaper. I think where the Ryzen 3 3000 parts will perform particularly well and will interest quite a lot of people is in small form factor gaming systems, perhaps a gaming HTPC, or a pretty high performance storage server. So you've still got PCIe Gen 4, you've got the benefits of 7nm when it comes to power efficiency, you've got pretty good clock speeds out of the box, and in an eco mode configuration with 45 watt rang down TDP, these could run pretty cool, pretty low power with good performance. And the key comparison needs to be made but unfortunately we don't have all the information at the moment, you have to wait a few weeks for that, is versus the upcoming Comet Lake S Core i3s from Intel. So these are going to come in at roughly the same price point. They're going to be 4 cores, 8 threads according to rumours. The frequencies are going to be competitive. So it'll be interesting to see how Ryzen 3 3000 fares versus those newer Comet Lake S parts. Of course they'll have similar frequency, similar core count, and this will be an interesting head-to-head fight because you're going to have some beneficial platform factors for the Ryzen chips, and you're going to have historic gaming preference for the Intel chips that we see with a lot of games, even to this day, with the likes of Red Dead Redemption and Grand Theft Auto 5. I guess the key comparison there will really be when we look at the overall platform picture. B450 and B550 on AM4 with high-speed memory support is probably going to be a better value option than the upcoming LGA 1200 options, but we'll have to wait and see. Can't make any claims on that. I would just suggest that you wait a few weeks if you are considering purchasing these. If you're still kind of on the fence, maybe just wait a little bit longer. But if you absolutely are dead set on a new system now, Ryzen 3 3000 with the Zen 2 architecture, I'm pretty impressed. So I've been Luke Hill for Kit Guru. Thanks for watching. Let us know what you think in the comment section down below. Are you going to go out and buy one of the new Zen 2 Ryzen 3 parts? Are you going to buy the Ryzen 5 1600AF if you can find it for a good price because you've seen that it's still a really good value king? Or are you going to wait a few weeks and see what Comet Lake S brings to the table at this price point? And let us know how you're going to use these chips if you are buying them. Small form factor gaming system, home server, budget build. Let us know in the comment section down below. If you like this video, give us a like, subscribe, hit that bell icon, do all that YouTube stuff. If you want to support us even more, check out our Patreon page. Head on over to the Kit Guru website where you can read the full written review with more detail. And if you want to really support us, buy one of these cool t-shirts. See you in the next one.